Hello, welcome to this talk. We are going to be explaining and doing some demos of new features in Entity Framework Core 2.0. Andrew, would you like to introduce yourself?
Sure. Hi, everyone. Welcome. My name's Andrew Peters, and I'm an engineer on the Entity Framework team.
My name is Diego Vega, and I am a program manager on the team. So let's start. So I wanted to start by explaining some of the different versions and flavors of Entity Framework that exist. If you have been following the evolution of the data access stack in .NET, you are going to be familiar with some of this. We have mainly two flavors of Entity Framework. The traditional older version or older code base, we call it usually Entity Framework 6 because that's the latest incarnation of that flavor. We have the newer and more lightweight version that is called Entity Framework Core. So these two boxes, large boxes in the slide represent two things that are very similar but also very different. There are similarities like they both provide object relational mapping functionality. When they are talking to relational databases, they both use ADO.NET under the hood, and they both provide link implementations. So you can write link queries in your favorite language and use them. But the difference is more important to talk about. First one, the Entity Framework version, the Entity Framework flavor was created many, many years ago. It was created for .NET Framework. It was designed at the time that I think that the priorities of the industry were a little bit different from now. Like we are not talking about cloud first and mobile first all the time, as we do now. So some of the decisions that were made on the design of this flavor of Entity Framework tended to be prioritizing, like running on very big servers with a lot of memory. That is one of the reasons we decided to create a new flavor, start with a new code base to support some of the same functionality, but in a way that is more lightweight, that also is more extensible. And also from the beginning, we wanted it to be cross-platform, to basically run anywhere there is a .NET implementation. So we created Entity Framework Core, and in this second version that we released recently, that targets .NET Standard 2.0. That means that potentially can run everywhere there is a .NET Standard implementation. That is, of course, .NET Framework 4.6.1 and .NET Core 2.0, but also other platforms. And that's a work in progress. We are testing it on different implementations of .NET Standard and trying to close all the gaps and all the issues that we find. Some of the themes of the new version are, well, it targets .NET Standard. You probably have heard about .NET Standard 2.0 a lot in .NET Conf. But it's this subset of APIs that you can target and guarantees that your code can run on different .NET implementations. We also had a big push for improving the quality and reducing the number of bugs that we had in the first version. Andrew, would you like to talk a little bit about the query improvements that we did, for instance?
Sure, yeah. I mean, building link providers that are capable of translating many kinds of queries is quite challenging, and so we've been working hard on that. We've made some good strides in 2.0. We translate a lot more patterns now, and we have some interesting features that we're adding to the link provider as well, which should help to allow you to write more expressive queries and just be able to write the kinds of business logic that you want in your apps.
Yeah. Another big push that we did was for performance. There were like several things that we wanted to improve when we profiled, especially ASP.NET Core applications using EF Core in the first version. We found that a lot of the time was spent creating objects for EF Core, and we did some improvements there. We also wanted to close the feature gap between Entity Framework 6 and Entity Framework Core because that's one of the main kind of feedback that we get from the community. And in particular, we wanted to address the lack of support for complex types in EF Core. And then every time we created a feature, we tried to do it in a way that we can reuse it later to enhance our capabilities even more.
Yeah, and I think it's worth pointing out there's always going to be differences in the features between EF Core and EF6. So EF6 will probably always have some things that EF Core does not have. But similarly, we've added a lot of things to EF Core that EF6 doesn't have. So it's worth focusing on some of those additions as well as the things that are missing.
Totally. Okay, let's start with the demos. So this is actually not a demo on a new feature, and it's not, I wouldn't consider it a feature. I think it's more of a continuum of different features that cover from the initial support that we had, let's say EF version 4, for simple POCO types. That's what we call plain all CLR objects or simple classes that don't have any dependency on EF, to something that is going to be much more flexible in the future, in which you are going to be able to model your domain in whatever way you want, and potentially we can be able to recognize more patterns and more types and be able to automatically create mappings to the database. So let's start with a very simple one. Let's switch to the code.
Okay. So as we can see here, we have just a small program. Most of the demos will follow the same pattern where we do some database setup. We have a little bit of example EF code. So in this case, we're creating a blogging context, adding a blog, calling this method on the entity called setURL, and saving changes. So this just creates the blog and adds it to the database. If we go down, let's look at the blog. Okay, we have this URL property here. Now we really don't want that to be a public property. Let's say we have this domain method setURL that actually does some logic, and we would prefer not to have it settable as a property. Even though it's private, sometimes it's just more appropriate to use methods, and we really want the flexibility to be able to create the shapes of objects that we want that are relevant for our domain. So let's see if we can do something about that. So one thing we can do is lose the property. We'll just get rid of that. Okay, so we need something else. We're going to use a field. URL. That's going to actually store the data, but it's not actually exposed now through the public API of the blog entity. We need to make a few updates here. And okay, so we can't read it anymore. We're going to do something about that in a minute. But here we're going to add a little bit of Fluent configuration that's available in EF to tell EF about the field, because by convention we will find that URL property, but we won't find the field. So we need to add a little bit of configuration for that. Let's do that. Field mapping. So what is this saying? During our model construction phase for the entity blog, we're giving it a property. This is its logical name, URL, but we're telling EF that it's mapped to this field, _URL.
Okay. Do you need to specify always the name of the field?
No, you don't actually in this case, because by convention we will, once you create this property, we will look for fields that follow some common coding patterns, such as _URL and lowercase URL. But in this case, we're just doing it for clarity.
Okay. What if there is no field in the class?
Oh, if there's no field in the class, EF Core has a new feature called shadow properties, in which we will maintain the value of the URL property, but outside of your entity, inside the DB context itself.
That's cool.
Yeah. Let's run it. Okay, another thing to point out for these demos is that we've got logging turned on, so we can kind of see what's happening. So here you can see the logging in EF Core 2 is a lot better. We can see we're creating the database here, create the table, and then query the blogs.
Great.
So we want to show that. So we don't have that way of reading the URL anymore. We can do a nifty trick. So this should show up red. We can actually query the value via the context itself just by using a few more of these public APIs that we have at the top level. So this one called entry takes a blog, lets you reference a property, URL, and then lets you access its current value. So here you can see we haven't been forced to change the shape of the entity in any way, but we're still able to kind of round trip the data. Run it. And now we're printing out the URL and the blog.
Yep. Awesome. So that's an example of field mapping, the ability to store state for the entity in a field that doesn't need to be exposed to as a public property, as normally we recognize public properties, but it's not required. It's one of those points in that continuum that I was talking about, in which we can support even richer mapping. Like if someday we expect that we're going to be able to support a dictionary, if you have a dictionary, or have a non-default constructors, or have collection methods. But this is some progress that we have been making recently on that. So let's switch to the next demo. I'm going to show in these slides DB context pooling. This is a feature that we created for ASP.NET Core. When, as I said before, we did some profiling of the first version, and we realized that we were spending a lot of time allocating objects and creating our dependencies. And if you have an ASP.NET Core application, normally you are going to have a controller that consumes a DB context instance. And what happens is that for every request, you are going to be resolving a DB context instance, a new DB context instance from the dependency injection container. And that's going to happen for every request. Therefore, if you have 1 million requests, then you're going to have 1 million instances of DB context. And Andrew thought, okay, we can probably reduce the cost of creating a new instance of DB context, but there is going to be a limit to that. So why don't we just create a pool of DB context that are pre-created and that we can serve to the controllers every time there is a new incoming request. So that works exactly that way. It's very similar to connection pooling, but not exactly the same, but the concept is very similar. If you are familiar with connection pooling, you are going to understand what's going on here. So every time there is an incoming request, a new instance of the controller gets created. Instead of creating a new instance of the DB context, we get one from the pool. And we do that again, until we empty the pool, I guess.
So if we have connection pooling, why would we need context pooling?
So I guess the answer is that the DB context has a bunch of dependencies. It has a whole tree of objects that it needs to create. And those objects are expensive to create. They need to be resolved from DI as well, but also they are expensive to collect when you are doing the garbage collection. So the less objects that you allocate in a request, the better performance you can achieve.
Makes
so let's
sense.
go to the code.
Okay, so we have another demo, and this one just simulates kind of at a high level what is going on inside a web application. So we spin up a bunch of threads, and then we just try and create as many context instances as quickly as possible. And we kind of keep track of how many we're able to create. So right now, this is just the normal kind of setup you would have in your startup. Add entity framework, SQL Server, add DB context. So pooling it is not enabled at this stage. So we're going to run this. Okay, so it looks like we're doing about 6.5K context creations per second. So that's not too bad. Now to enable pooling, it's quite nice because we implemented it at the DI layer. So you really just need to change one line in your startup. Now what this does is registers the pool into DI with an indirection so that when any of your components, such as a controller, needs a context, it will come from the pool. So the way you need to code your controllers is the same. There are no changes to user code.
You got too many letters there.
Oh, yeah?
This is DB context pool.
Pool, yeah, that's true.
You created that API.
I did. Let's run it. Okay, so we got a nice jump. We're doing like 9.5K or something requests per second now. So that's really just context creations. And here you can see, after we create the first 32 instances, we haven't created any more. So they're all just going in and out of the pool.
That's great.
So there are a few caveats to pooling, and that's why we haven't enabled it as the default. When a DB context is returned to the pool, we need to make sure we can restore it to a pristine state. And we know how to do that for all of the internal state in the DB context. But if you have any user level state that you've declared on your derived DB context, at this stage, we don't know how to reset that. So we don't enable pooling by default. We consider it more of an advanced case.
So state that you create in the DB context and you hold, it would lead to the next request.
Yeah, potentially. Let's say you had a tenant ID field or something similar to that. We wouldn't know how to restore it to a new value if it needed to be reset.
Okay, cool. So the next demo, the next feature we're going to talk about is a explicit compile query. So this is a feature that we actually had in the original EF. We had it in the beginning. We kind of removed when we added the DB context API because it became very hard to use. But it's about creating your own delegate variable that can hold a reference to a query so that we don't need to do any lookups in the query cache. For LINQ, that's important because the ability to query the cache and to look up in the cache, we need to basically come up with some representation of the LINQ expression that is relatively expensive. I mean, it's not too expensive, but it's relatively expensive to compute. So we decided to bring it back in EF Core 2.0, basically for people that need to get the latest bit of performance out of the hardware in ASP.NET Core applications.
Yeah, as Diego was saying, another fairly advanced performance feature, but one that can help if you do identify that query cache resolution is a bottleneck or is causing your app to slow down. So let me just talk about how it works in the normal case. So we have a normal query here, and we call this an auto-compiled query. And what that means is that the first time it runs, EF will generate a cache key from the input query and use that to store the result of compiling the query into its own internal cache. So when we run a query, we actually compile it the first time into something that knows how to run it because it's actually expensive to translate the query. So this is what you would normally use, and this is fine most of the time. We think it adds approximately 3 to 5% to do the query cache resolution. And if that's meaningful for you, you can actually switch to explicitly compiled queries. So in an explicit compiled query, we still compile the query, but instead of putting the result in the cache, we just give you back the result. And you're in charge of managing the lifetime of that thing. So let's create one here with a snippet. So here, this is how we create an explicit compiled query in EF Core 2. We have this entry point here, which is a static EF class, which just provides a nice, concise entry point into some static APIs that we have. And on that, we have compile query. And this thing is very similar to the way you would write it normally, except that you give it a lambda, and that lambda is parameterized on two things. One of them is the context instance that will actually be used to run the query, and then any number of arguments that you want to be able to pass to the query. So values that are changing each time you run the query, such as the ID in this case. Let's just run this first, just to see how the normal approach performs. So I'm not actually running the compiled query yet. I've created it, but I'm not running it. So the regular auto-compiled query took 230 milliseconds. Now to invoke it, because this thing returns a func, we just need to invoke the func just by calling it. And we pass it the context and the parameter. So both times we're just looping over a set of account numbers and running a query for each one.
Okay, do you know how many times we're executing the query?
Account numbers.
Okay. Bad question.
No, that's fine. 500. There
Okay.
it is. So let's run it again. Okay, so in this case we got a pretty good speed up. I don't think you would typically expect to see this kind of improvement, but for this particular query and this data set, then we actually got it much faster.
Yeah. So one tip for this is personally, my favorite way of using this is to create a static field on the dbContext class, and then wrap it into a method that just takes these dbContext as the first argument, so that for any code that is outside of the dbContext, this is easier to consume.
Yeah, that's kind of a nice pattern. And I think we made this creation code much nicer in Core 2. Yeah.
Yeah. Do you want to talk about the EF class, by the way? I think that's an interesting piece that we need to educate people on.
Yeah, so the EF class, there's a few places in EF where we just have static entry points. So one of them is compile query. Another one is, we were talking before about shadow properties.
Yeah.
When you want to query a shadow property, because there's no corresponding CLR member to put inside your link query, you can use ef.property as the common way of doing that. So that's that guy.
Yeah.
And so you just pass it the string and the type, and it's kind of a late bound way of accessing a property.
Yeah. So the goal in general is that for any API that you need to use in EF Core, it's either going to be on the dbContext, so it's going to be applicable to the dbContext instance, or it's going to be hanging off the EF class, so that it's more discoverable.
So I've had a few questions. Do you want to, should we pull some off?
I was thinking about taking those questions when we talk about the roadmap for the next version, because they seem to be very roadmappy.
Sure.
Okay. So the next demo is about own types and table splitting. This is a very interesting take that we took on the problem of complex types. So we had this goal that was to say, okay, we're going to close the gap with Entity Framework 6. We are going to provide complex types functionality. If you're not familiar with that, the idea is that you have a class that is not an entity. It doesn't have its own identity. The canonical case, we can show it in the code, is you have a customer and each customer has an address. And that address really depends on the customer. It doesn't have its own ID. It doesn't get mapped to a separate table. It's mapped alongside all the same properties of the customer. But you want to organize the data in some way, so you create this nested class. And when we were exploring how to address this scenario, we decided to come up with something a bit different in EF Core and a bit more flexible. And that's when we talk about reusable building blocks. I think that this is what we did here. So we created two features, which is own types and table splitting. Own types is a very similar idea to complex types. Is the idea that there is an entity in the model that has its own identity, but its identity is actually borrowed from an owner entity and also from a navigation property that is pointing to it. Therefore, in order to address one of these own types, you need to always go through the owner and the navigation property. From the perspective of the CLR object or the .NET class, you don't have any ID on the object itself. The other thing that we are getting in this release is table splitting. Table splitting is the ability to say, okay, I have several objects. They have a one-to-one relationship, and I want them to be mapped in the same table instead of having split tables that have a foreign key relationship. So combining those two features, we have exactly the same thing that you had in EF6 with complex types, but because we build it in this way, it's also a superset. We can do many things here that you cannot do in EF6. Do you want to show the code?
Sure. So a good thing to ask would be what are some things you can do in own types that you wouldn't be able to do with complex types?
So for instance, we wanted to have navigation properties. In EF6, we had the ability to have nested complex types, but we couldn't really point to a different entity from a complex type. In EF Core 2.0, we can.
Okay. So I'm just doing a bit of basic Fluent configuration here. We see we have this new Fluent API owns one. And so what this is really doing is setting up ownership between the customer and the address properties via this navigation property work address. So that's another thing with own types versus complex types, is that we just use navigation properties in the same way we would between entities. they're not a special kind of property as they were in EF6. They're all just navigation properties, and they all just point to entities. And the entities can either be fully fledged or they can be owned. So when we run that, oops, let me just change the startup project, sorry. You do that every time. Okay, so in this demo, we're just going to create the database every time, and we'll see the changes in the database structure as we make kind of changes to the Fluent configuration. So right now, in the first iteration, what we've done is we've mapped both address-owned types into the customers table. So this is leveraging the table splitting that Diego mentioned. And we can see we're using the same kind of convention we used in the past to name the columns. So we use the name of the navigation property and then the corresponding property names of the own type.
Okay, so I noticed that you have two instances of the same type as two different own types in this code.
Yep.
Okay, and is one of the features that I remember we wanted to achieve was to say, okay, mapping it on the same table, which was kind of mandatory in EF6, now it's optional, right?
Yeah, so that's another advantage, is that because it's just another kind of entity type, we could actually send it to a different table. So let's send the physical address to physical addresses, something like that.
Yep.
Okay, that looks good. So now we have the customers. It still has the work address embedded, but the physical address has been split out, and we've set up a relationship between those two tables.
That's great. Do you have anything else on types?
It's worth pointing out that they can be nested, and as Diego said, they can point to other entities. So we could create a country entity, and then we could have a navigation on the address class that points to that.
Yeah, there is a limitation that is by design, which is only the owner can point to the own type. There is no other entity can point directly to the own type. So one thing that we are planning in the future is to enable collections of own types. And when we have that, I think we are going to have a very high fidelity way to model aggregates in EF Core. That's going to be great.
Nice.
So the next feature we want to talk about is global query filters.
Okay.
That's something that you need when you say, okay, for this context, let's say that every time I query for a specific type, I want to always apply the same filter. Besides anything that you put in the where clause of the query, you want to always be applying an additional filter. This is useful for things like soft deletes and multi-tenancy and any other scenarios that you can think of for filters.
Sure. So
Let's
this
switch to the code.
Yeah, this is a good example of something that we have in Core that we don't have in EF6. So in this little demo, we are doing the blogging context again. We're running a query, blogs, including the posts, and then we're just writing them out. So let's see where we stand. Okay, so you can see we have the blogs, and we have these properties on each one, tenant and is deleted. So this is, in this demo, we're going to implement multi-tenancy using the tenant flag and soft delete using this is deleted flag. And what we want to have at the end is this query should respect the values of these things. So if the tenant is Rowan, we shouldn't get the blog for Jeff. And if the rows are deleted, we don't really want them to come back by default. Okay, so let's go down. Here you can see the implementation. So we have the tenant ID, the is deleted flag. Now we do some work in save changes. This is the corresponding part of the functionality that isn't in the query side. So filters are really about query at this stage. So if we really want to implement soft delete and multi-tenancy, we want to do something in save changes to make sure we get the right values for these things persisted. So we just detect all of the entries that have been deleted, set the deleted flag to true,
Cool.
and then we set the current value of the tenant ID when we are making updates. Here you can see we're using a field mapping again.
Uh-huh. So you don't need to expose the tenant ID as a property on the class.
Yeah, that's right. Let's add the tenant filter. So this is another new Fluent API in 2. So has query filter means whenever we generate a query for an entity of the given type, we will apply this filter. Now there's an opt-out for this at the query level, but by default, this is what we'll apply. And the advantage of this over, say, just always manually specifying the filter in your individual queries is that A, it will happen in one place, it's dry, you don't need to remember to do it. And also, yeah, let's run this, let's see. Okay, so now we're only getting the row and tenants. Oh, sorry, just forgot to mention the other advantage is that for include queries, there wasn't a way to apply filters. So EF will apply the filters to the include queries as well, and we're going to see that with the deleted flag.
Okay.
Let's apply that.
So you are getting the underscore tenant ID from a field on the context, right? So can you?
Oh yeah, that little bit of magic. So it looks like we're defining this filter fragment once because on-model creating only runs once. So it might look like that we're only going to read the value of tenant ID at the time that on-model creating is run. But what we do is we recognize that this is kind of a valuable pattern to be able to parameterize your filters based on context state. So what we do is we actually turn this into a parameter in the filter, and then we take the value from the actual context instance that is running the query at that given time.
That's awesome.
Yeah.
I think.
Soft delete. So this will show that the filter is actually being applied to the include, because if we look back at the top, you can see we're not directly querying the posts, but we're rather including them from the blogs. So we want to retrieve all the posts that aren't deleted. Okay, so now we've implemented multi-tenancy and soft delete using some of the building block features.
Excellent. Thank you. The next feature we want to talk about is support for string interpolation in raw SQL queries. You want to show?
Sure. Do you want to talk a bit about that? I'll just
Yeah,
keep
so
this
this is a feature that came up in C# 6.0, I believe, that people are very fond of, and particularly we are very fond of as well. The thing is that when the C# team created this feature, one of their goals was that it could be used to make APIs that concatenate SQL in a safer way. And we actually took that hint and we decided to implement it in Entity Framework Core. And we have this, we call it escape hatches that you can use on. They are APIs that allow you to write SQL directly instead of going through LINQ. And you can also execute simple commands that don't return rows. And we have several patterns to parameterize those queries, but they are not as nice as interpolated strings. So we wanted to add that capability.
Sure. So this is the traditional way that we have supported allowing you to provide strings of SQL with parameters in a safe way. From SQL, give it a more traditional .NET format string, so a non-interpolated string, and then you specify the parameters afterwards. And it's pretty easy to see how we can parameterize this because we just have the placeholders and the values, and we just do the right thing. So let's just run that guy. There's a fish. What was it? Just trying to remember what to search for. Okay, so we're generating the query, and here you can see it's correctly parameterized.
Cool.
So we want to point out kind of what we've done isn't perfect. There's still places where it can fall down with string interpolation. And in particular, there's a naive pattern. Which is this. So here you can see we're using string interpolation, but we're actually putting it into a local variable. Now what this will still do is give you the potential for SQL injection attacks, because you're not using our from SQL API, and we're going to explain why in a minute. But we just wanted to point out that you still need to be careful when you're using this feature. We think we've made it better by closing one of the potential places you can fall down, but there's still a risk with this kind of pattern, because what happens is by default the compiler will just embed the term value straight into the string, and we won't have a chance to do the parameterization. There's a few things you can do to mitigate that as well. Maybe I'll run it first and then we'll talk about that.
Yeah.
So in this case, because we're searching on a string, the parameter is incorrectly quoted, so it's actually crashed, which is better than it allowing to do a SQL injection attack. But if this was user input, this would still be like an attack vector here. Should we just touch on the safe way?
Yeah. Or we can go back to it.
Yeah. Let's show how you can do it safely using from SQL in Core 2. And that is that you just need to be inlining the interpolated string in the from SQL call. We introduced an overload that will detect this and actually turn this into a parameterized SQL. So here you can see you've used the interpolated string, but it's still parameterized safely. So let's just go back and now in order to target the correct overload that does the parameterization, you can actually, we haven't tested this, but force the compiler to use a special type, formatable string. So this is the actual type that we use to do the overload resolution when you actually pass the interpolated string inline in the call.
Okay. And what is this type about?
So this is the type the compiler uses when it expands interpolated strings. So it actually expands it out into it can expand it out into a traditional format string with the placeholders, and then also give you back an array of the values that were inside the string. So we use this to sort of unpack it.
That's awesome. Thank you to the C# team for doing this. Okay, so next we wanted to talk about some of the roadmap that we have for new features. If we get any time at the end, we can do something else. But I was thinking that we have questions that are very much about the roadmap, so we can start with that. So Anil is asking, will EF Core 2.0 fully support Xamarin, and when? I can answer that. So currently we are working with Xamarin, and we are working with the community. We have had a few issues reported. From what we hear, Xamarin on Android works pretty well, but Xamarin on iOS compiles to native and has a few limitations that our code is hitting. We have seen several bugs reported. Things have improved from the previous version of EF Core, but now, for instance, if you have an entity that has more than a certain number of properties, then you are going to hit the problem of the way they invoke methods dynamically. That is something that is going to happen when you are executing queries in EF. So it's a work in progress. We are making progress. iOS doesn't work completely yet, but many scenarios apparently work. And with Android, it works better. So the next question is Hishamko is asking if there is any plan to create a DocumentDB data provider. We are actually talking to the Cosmos DB team. They own the DocumentDB API, and we are starting work on a provider for this DocumentDB API. And we are going to have some more news soon. The idea that we have is to have something working at least in preview for the 2.1 timeframe. Another question related to the roadmap is what happens with Oracle. So we are actually working with the Oracle team to have support for AD.NET in .NET Core and .NET Standard, and also to have support for EF Core. They have published a plan in their website. If you want to go to the odp.net website, you are going to see some news and some estimates. I cannot speak for them, so I'm being very careful. But the other thing that we are doing with them is that we work on a sample, and I think that you can talk about that better than I.
Yeah, so I think we know that Oracle is possible because we're just running an initiative at the moment to create a few samples. And so the first one we did was a sample Oracle provider. It's by no means production quality, but it passes 95% or more of the EF Core functional specification tests for providers. So we have a NuGet package, which is a specification test set that providers can run to see how much of our kind of contracts they implement correctly. And so we did that, and it's looking good. But as Diego said, we need a few things from Oracle. They need to make a .NET Core ADO provider, and then the EF provider that's production quality.
Yeah. So the next question, I think that Andrew, you can also respond.
The question is there a limit to the number of DB contexts that are created in the pool? Yes, the limit is something that you can set. It's the pool size that you can pass to the enable pooling API, the add DB context pool. So that has an optional parameter, which is the max pool size. So once the max pool size is reached, if more requests come in, we will just create new instances. So effectively, you fall back to the normal mode, which is you're just newing up context instances, and so you're not using the pool, but...
Yeah, I think it's a subtle difference that even I had a little trouble understanding, but it makes sense once you understand it. It's like we don't want to block the creation of DB context. We don't want to slow down the application or to block a thread because there are no more DB contexts available. But we want you to be able to choose, okay, this is the limit. This is how many DB context instances that are not being used that I want to preserve in memory.
Yeah, and where that might matter is if you have, say, like bursty traffic.
Yeah.
So the pool, if it was allowed to grow arbitrarily, it could grow out to, let's say, 500, and then if your traffic dies off, you've kind of retained all that stuff. So it kind of caps how much it can grow.
Yeah, that's also it makes it a little bit different from connection pooling because connection pooling actually puts a hard limit on what you can create.
Yeah.
So we have just answered the next question as well because it was about the same thing. So the next question is, now that EF Core 2.0 targets Net Standard 2.0, do you have any advice on a developer wanted to use EF Core 2.0 features but is building UWP apps? And I cannot see the rest of the question right now because we need to delete the first one. The previous question was already answered, so we can get rid of it. So anyway, the solution is that there is this incoming new version of UWP that supports Net Standard 2.0. There is actually a preview out. If you install Visual Studio 15.4 previews, that includes the new version of UWP for .NET. And EF Core 2.0 runs there. There are a few limitations. There are a few bugs that we found after we had closed down on 2.0. But the plan is to have them resolved in a patch that we are planning to have out. And while you have to wait for the patch, you can probably also use one of our nightly builds to resolve those issues. There are some limitations that you can work around by adding metadata to this RD XML file, but there are a few on query that are not that easy to work around. So we are working on that. For older versions than for creators, that is the rest of the question, you really are stuck with the older version of Entity Framework core. You are going to have to use 1.1 point something, depending on what is the latest patch. We are not planning to backport EF Core to use an older version of Net Standard at this point. So the next question is about GraphDiff related functionality. Given an object, the ability to update associated entities. It says there are extension libraries, but any idea if this will be incorporated into the base? So there is something that we have in the backlog. We call it the merge method because there is a very similar functionality in Hibernate. It's probably not going to work the same way as it works in Hibernate, but it's something that we would like to do eventually. It's not the highest priority, so we don't have it in the roadmap for 2.1, but it's in the backlog. And we would accept a community contribution on this.
Yeah, I think...
accept or consider, at least.
Yeah, and is it worth talking about some of the ways in which we changed how that behaves?
Mm-hmm.
So we added track graph, so that at least provides a way for you to paint state more easily.
Yeah. Yeah, the other thing that we had in EF, in the older version, or EF6, was that we were very strict about every mutation on the state of the graph to always leave the change tracking functionality in a consistent state. So you could not have, let's say, an added object pointing to, an existing object pointing to an added object, because that's impossible in the database. You cannot have that situation. And now we give you more freedom. If you are using this entry API that Andrew used earlier and you change the state of an entity, then that's going to have no side effects. So you can create your own logic that is going to paint the graph in a specific state without worrying about side effects. Is there better support for private fields mapping in EF Core? Well, we just demoed private field support. There are things that we still haven't done, like we would like to have a nicer API pattern for navigation properties that are in private fields, but I would say it's supported already.
Yeah, I think the two main things we did were make it so that we can actually set the value of fields. So we didn't have that before. So we can read and write to fields, so that's fine. The other thing is you can refer to those things in queries using that EF property API that we showed. So there are like string-based APIs in code first and in query that let you talk about logical properties that are backed by fields.
Okay. So the next question is whether we are going to have the samples available after the show. And actually, we have a slide that I'm going to show in a few minutes that has a URL for that. Andrew has a repository in GitHub with these samples. The next question is, why the direction to have features in Core that are not in EF6? Core seems inherently responsible for being the base that EF6 should derive from. Actually, that's not the way we think about it. One of the reasons we created EF Core was because evolving the EF6 code base was becoming very expensive, especially when you have like a very huge installed base of customers. You don't want to break them. And we believe that the way we deliver the most value, or we optimize how we deliver value on EF6 is by just evolving it very conservatively, I guess, and adding some improvements, but without breaking any of the functionality. And it was becoming really expensive for us to come up with new ways to do that and to introduce new features. We wanted to do things like unique constraints on EF6, but it was really prohibitive.
Yeah, I mean, I think we could say that we made some philosophical and architectural changes in EF Core, and those were what Diego alluded to at the start of the talk.
Yeah.
So, for example, in EF6, it was very much based around the entity data model. So this vision that we would have a data model that could live outside of the OR mapper, that would be valuable on its own. That was fine, but that took a lot of code and extra wire up and just stuff that we don't actually need if we just want to be lightweight. So we were very much focused on being more targeted, specific, leaner in EF Core.
Yeah, and I think we are evolving it much more quickly than we could ever evolve EF6 code base.
And that's another reason why we can add features to EF Core that maybe are really hard to add to EF6.
Yeah. So on the flip side of that question, I think that we want to eventually add many features in EF Core so that it's never going to become a superset of EF6, because we actually don't want to do everything that EF6 did. Actually, it would become less lightweight if we did.
Yeah.
But we want some specific features we get a lot of feedback on, like lazy loading, table per type, inheritance hierarchy, and group by translation is one of the things that we're doing very soon, that we are planning to close that gap.
Yeah, and we really want to hear from everyone. So make sure you come to our GitHub repo. There are lots of issues for these things already. So we look at the sort of activity on those things. You can add the like or whatever, or just file new issues. And also, if you see something that's low-hanging, feel free to send us a pull request. We really value contributions, and we take all of our pull requests pretty seriously.
Okay. So we have many features in the plan for 2.1. Some of these are things that we have committed to do, and some things we have committed to start in 2.1. We have a data seeding, like a replacement for the old seed method that we had in EF6. We have mapping types without keys. That's probably something that you want to describe, but we have just a short time.
Sure, yeah. So one thing we want to ship in 2.1 is we roughly call it view types, but it's the ability to define classes in your model that aren't actually entities and that don't need a key. So a canonical example of this would be you have a database view, you want to be able to query it. It's read-only, obviously, it has no key, but that's fine because you just want to display it in a UI. So we're going to add something like that, and we're going to leverage our existing metadata system to make that cheap to implement and powerful as well. So you should be able to use inheritance and navs and all that stuff with these things.
Yeah. If you are able to run nightly builds from 2.1, from our 2.1 development branch, you can see that some of these features are already in, like support for system transactions is already in, although we are not picking the right dependency to have support for system transactions in SQL Server yet on .NET Core. We have the data seeding bits, at least the start of it is in, and we have the sample Oracle provider already in. And I don't see anything else in the list that include for derived types is already in as well, right?
Include for derived types is in, and group by is very close.
Okay, cool. So next slide is some resources for this talk. I mentioned before that we have the demos. That's the last bullet point. That's Andrew's GitHub repo for the demos. And we have documentation in the Microsoft Docs website. We have our project repo on GitHub. We have the blogs. We actually blog on the .NET blog. So anytime you want to get updates on what we release, every time we release a preview or any other kind of announcement, you can subscribe to that. Thank you very much for being today, for watching us today. And I hope that you are going to find this useful.
Yeah, thanks a lot. Make sure to hit us on GitHub and let us know.
Thank you very much.